All of us as children, at some point in our lives, have gazed at the night sky and wondered, are we really alone in this universe? Our parents and grandparents huddled around their radio stations and television sets, listening to the crackling reports of Neil Armstrong taking the steps to become the first man on the moon. Despite the intense rivalry between the United States and the Soviet Union, the space race was more than a competition. It was a shared endeavour which allowed all of mankind to take big strides forward, to explore the great unknown outside of our planet. Yet for nearly 40 years, progress stagnated, until a new group of visionaries stepped onto the scene. These billionaires, who revolutionised our shopping habits and the cars we drive, have rekindled our dreams of space exploration. This new space race has led to some of the most exciting progress we have ever seen, turning science fiction into reality. In this video, we'll explore the biggest players in this second space race, the spectacular progress that's been made, as well as some of the challenges that lay ahead. SpaceX, spearheaded by Elon Musk, is leading the way for space exploration. Just imagine one day your great-grandchildren being able to see the red sands of Mars beneath their feet, looking up at an entirely new sky. Now this new world could be made possible by SpaceX's Starship. With different variants of Starship being developed, the Crew Starship is a spacecraft designed to take up to 100 people to and from Mars. Here the goal is audacious, to colonize Mars. Starship's engine, Raptor, is the most advanced rocket engine created. What's remarkable is how energy efficient this engine is. It's unlike anything we've ever seen before. So let's dive a bit deeper. What makes the Raptor engine so unique? Well, it's what we call a full flow stage combustion engine, which is a fancy way of saying that it uses all of its fuel, methane and liquid oxygen, to propel the Starship. It has a theoretical combustion efficiency of 98.5%. A normal petrol or gasoline car only uses about 30% of its fuel to actually drive the car. So with the Raptor engine, it's like having a car that uses pretty much every single drop of gasoline you put into it. But why is efficiency so crucial? Well, here's the thing. The cost of developing and manufacturing rockets is sky high. Every ounce of fuel, every piece of material, every minute of labour counts. We must find ways to make space travel not just a dream, but an economically viable reality. We wouldn't throw an aeroplane away after it's travelled to its destination. So why would we do the same for a rocket? SpaceX's focus has been on reusability and efficiency in order to reduce the total cost needed for space travel. And Starship is leveraging their existing model of reusing rockets, as showcased with their Falcon 9 spacecrafts. Starship is made up of two distinct parts stacked on top of each other, or stages as they're called in rocket engineering, where each stage has its own set of engines. Its first stage, called the Super Heavy Booster, separates from the spacecraft after launch and returns to the actual launch site autonomously. Here it will vertically land and actually be caught by the launch tower. Think of it like using massive chopsticks to catch a rocket. Its second stage, the actual Starship spacecraft, once completing its mission, returns to Earth by completing a belly flop maneuver before vertically landing. So much effort has gone into enabling this, so that Starships can be reused to help make space travel economically viable. It's constructed using stainless steel, instead of using traditional materials like carbon fibre. Stainless steel is better at withstanding the extreme high temperatures generated from the launch pad and entry back to the Earth's atmosphere from space. Starship is one of the largest rockets you will ever see, but here's where it gets tricky. If a rocket mass increases, the energy required to launch that rocket increases massively. So here, the rocket engineers at SpaceX will try and lower the total mass, where with the same amount of fuel, the rocket can travel further and deliver a larger payload, which could be satellites or even a group of humans visiting Mars. That's why Starship wants to catch its Super Heavy Booster, rather than adding landing legs to the booster, which will increase its overall mass. But let's take a step back for a moment. Making space travel economically viable isn't just a numbers game. It's about something bigger. It's about breaking down barriers. We're striving for a future where space travel isn't an occasional, headline-grabbing event only for the privileged few. it's about democratizing space travel. So how does SpaceX plan to actually make money with space travel? Imagine Starship as a cosmic delivery truck. It could amplify its existing capabilities to launch not just its own Starlink satellites, but also those for governments as well as other businesses, helping us monitor weather patterns and even help with communication across vast distances. Another source of income is from securing contracts from NASA. As part of NASA's initiative to explore space, let's travel back in time to 2021. NASA offered SpaceX a contract worth $2.9 billion. The mission? The Artemis program, a bold initiative to send the first woman and the next man to the moon by 2024. In fact, for over 10 years, SpaceX and NASA have maintained a commercial relationship, where SpaceX's Falcon 9 and Dragon spacecrafts have been transporting cargo and astronauts to the International Space Station. SpaceX is not just a participant in the new space race, it's pioneering it, and their unique approach gives them a significant edge: vertical integration. In contrast to other firms, SpaceX designs, manufactures, and tests almost all components of Starship in-house, from the Raptor engines that propel the spacecraft through to the stainless steel structure that withstands the intense heat of re-entry. Each part is crafted with meticulous detail under the same roof. So why does this matter? Well, think about it this way. By creating all the puzzle pieces themselves, SpaceX ensures that they fit together perfectly. They can identify and solve problems faster, without waiting for a supplier to deliver a part or a solution. As we witness these innovative updates from SpaceX, it's time to turn our attention to another player in this field. Blue Origin, founded by Jeff Bezos, is a serious contender in the space race. Bezos' lifelong fascination with space, sparked by watching the Apollo moon landings as a child, is a driving force behind Blue Origin's mission to enable millions of people to live and work in space. Following a similar approach to Starship, Blue Origin's arguably most exciting spacecraft being worked on is the New Glenn. Named after the astronaut John Glenn, the first American to orbit the Earth, the New Glenn stands at an awe-inspiring 270 feet. To put that into context, that's about the same height as a 25-story building. Its first stage, the part of the rocket that lifts it off the ground and gets it out of the atmosphere, is equipped with 7 of Blue Origin's most powerful engines, the BE-4. These engines are uniquely powered by a combination of liquid oxygen and liquefied natural gas. These 7 BE-4 engines are capable of producing a staggering 3.85 million pounds of thrust. That's about the same amount of thrust as 20,000 cars all accelerating at once. New Glenn's ambition extends beyond its size and power. It's designed with versatility in mind, capable of launching commercial satellites, deep space probes, and potentially even human missions to the moon. But Blue Origin has faced hurdles, with progress slower than anticipated. Now, despite their launch day of 2024 raising eyebrows, even a pushback by a couple of years to 2026 will still be commendable in the grand scheme of things. Now let's turn our attention to Britain's most loved billionaire, Sir Richard Branson. With Virgin Galactic, Branson, a man known for his daring pursuits, is now charting a path beyond our atmosphere with his unique approach to space travel. Taking a different route from SpaceX and Blue Origin, Virgin Galactic are carving their niche in suborbital space travel. It's like a roller coaster ride to space, just high enough to give you a stunning view and an unforgettable experience, without actually orbiting the Earth. Their spacecraft, the Spaceship Two, is designed to take 6 passengers and 2 pilots on a 90-minute journey. Its mothership, the White Knight 2, carries the Spaceship Two to a height of 50,000 feet, almost twice the height of a cruising airline. Then, Spaceship Two detaches and propels its passengers towards a starry sky. Once it's in space, the rocket motor is turned off. The spacecraft is essentially in freefall around the Earth before it eventually descends back down. From a financing standpoint, Virgin Galactic's unique position as a publicly traded company opens up an avenue for public participation in its vision, and furthers its goal to make space accessible to everyone. And the recent announcements are exciting. A fully crewed spaceflight will be expected to go ahead in May of 2023. Here, the objective with this mission is to make a final assessment of the spaceflight experience before commercial service begins in late June. While we should be marveling at the unprecedented progress made by companies like SpaceX, Blue Origin, and Virgin Galactic, we shouldn't forget that they're not just competing with each other, but they're also competing with states. Countries like India, Russia, and China have also cast their eyes towards the stars. However, they currently lag behind the US in this second space race. India, a country brimming with potential, is planning to launch their first manned spacecraft in late 2023 or even early 2024. Russia, once a titan in space exploration, is now being slowed down by economic sanctions. These cuts are expected to lead to a decrease in the number of launches and development of new technologies. Meanwhile, China has made considerable strides. In 2021, they launched their first ever space station, Tiangong, and China's ratio of useful payload to orbit is comparable with that of SpaceX's. However, despite such accomplishments, their rocket engineering is still some way behind that of SpaceX's. China hopes to make reusable rockets by 2035, but SpaceX is already doing this today. So even with their status as a global superpower, China has lots of ground to cover in this second space race. Earth, while ideally being suited for sustaining life, presents significant barriers to leaving its atmosphere. The physics associated with the gravity of the Earth, alongside its extremely thick atmosphere, makes launching rockets from Earth almost impossible. Out of the entire mass of the rocket, only a tiny 2 to 3% of the rocket's mass can be the payload, like satellites or human astronauts that make it to orbit. Tiny mistakes in design, manufacturing, or fueling can have significant consequences, leaving virtually no room for error. At every part of the rocket launch, there is so much complexity involved in getting things to work together. On April 20th, 2023, SpaceX launched their first Starship prototype. This prototype launch saw the vehicle fail to reach orbit less than 4 minutes after liftoff. Post-mortem analysis has shown on liftoff, 3 of the 33 engines were not healthy enough to bring them to full thrust. An explosion also occurred, which removed the ceramic heat shields of engines 17, 18, 19 and 20. Now, whilst the mainstream media were quick to criticise, staff at SpaceX highlighted this first launch actually exceeded expectations. With valuable data captured, the SpaceX team can now use this data to increase the likelihood of future success. But perhaps the most serious failure was associated with Virgin Galactic. In 2014, one pilot was killed and another injured. The crash was caused by a problem with the spacecraft's braking system. So whilst we do aim to reach for the stars, we must also brace ourselves for the sobering realities that come with it. The risk of technical failure, and tragically, the occasional loss of human life. But we must not lose sight of the sheer amount of outstanding progress made in space travel in the last few years. In his famous pale blue dot reflection, Carl Sagan reminded us that our place in the universe is small, and how Earth is just a point of pale light in the vast cosmos. But this shouldn't make us feel insignificant. In fact, it should inspire us. Neil Armstrong said how landing on the moon was a giant leap for mankind, and all of us, I'm certain, will start to see more and more leaps unfold before our very eyes. Until next time, thank you for watching.